Welcome back to the Scotti-BYTE channel, and this is Scott. Today I want to talk about Incus profiles. And so when you install an Incus server, you get the default profile. And the default profile is used by default whenever you create a container. And so the default profile defines the ETH0 device to be bridged through LXD BR0 if you had installed a LXD server and upgraded to Incus, or the Incus BR0 device if you've done a from scratch install of Incus. And it defines the root file system to come out of the default storage pool also. So if you watched my Incus Containers step-by-step tutorial, you learned how to add the bridge profile, which bridges your containers to the main LAN, unlike LXD BR0 and Incus BR0, which bridge your containers to the main LAN but maintain an address on the internal NAT network. So in my LXD profiles tutorial, I showed how to use profiles for other purposes as well. So this time, I'm going to show various examples on how to create, use, and modify various Incus profiles. Here I am on my desktop Incus server, and as a reminder, if I do an Incus profile list, on this machine I have a number of profiles. But the ones that we want to look at are the default profile first of all, and if I do an Incus profile edit default, you'll notice that the default profile defines both the network device inside the container ETH0. In this case, it's pointing to LXD BR0, and part of the reason for that is because this Incus server was migrated from LXD. If you have a newly installed Incus server, then you're going to be pointing to Incus BR0. And then the second thing that we have here is the root path for the default disk for inside of a container, and that's going to point to the default pool and to the root device. If you followed my Incus Containers step-by-step tutorial, then you also have the bridge profile, and if I do an Incus profile edit bridge profile is simply a profile that defines NIC type equals bridged, and it points out to our parent device bridge 0, which is a virtual switch, and so it provides containers that use bridge profile and address on your main LAN. So let's go ahead and launch a new container by the name of test1 with an Incus launch images :ubuntu/2404 test1, and we'll set boot.autostart equals to true. And now that that container is started, let's go ahead and perform the updates inside of that container with the command Incus exec test1 --apt update. And after it performs the update, which you can see that all the repositories are up to date, let's go ahead and install the Apache web server inside with a Incus exec test1 --apt space install Apache-y, and that will install the Apache web server. If you noticed, when I created the test1 container, I did not use the bridge profile, and so the Apache web server that we just installed on container test1 would not be reachable from outside of this particular Incus server. So we're going to go ahead and fix that with the profile, and what we're going to do is an Incus profile create proxy-8080. And the proxy-8080 profile will have the following characteristics that we're going to add to it. We're going to do a device add to proxy-8080, and we're just going to call this association host port 8080, and the proxy is to listen on TCP port 8080 from the outside of the network. In other words, the address of the Incus host, very similar to what we do with port proxies in Docker. And then we're going to connect inside the container to the address of the container, 127.0.0.1, simply the loopback address, and then at port 80. And if we look at that association that we just created, we can do an Incus profile show proxy-8080, and there's the definition. You can also do an Incus profile edit proxy-8080, and you could go in and edit and make changes to it. So at this point in time, let's go ahead and add our proxy to the container test1 with Incus profile add test1-proxy8080. If I go into my web browser and I access the address of my Incus server, I get a "this site cannot be reached," and that's because I didn't have any route inside of the container test1, which is a NATed address. But in virtue of the proxy, I can go to the address of the Incus server, which is 172.16.1.225, and I can say go to port 8080. And port 8080 is proxied inside the container to port 80, which is where the Apache web server is running. Proxying a port from a container back to the address of your Incus server is an alternative to using the bridge profile and providing your container its own address on the LAN. The only downside to using the proxy alternative is the fact that if you had 5 containers that needed access to a web server, as an example, you would have to pick a different port number for each of those containers because of the fact that they would all be using the Incus server IP address on which to host. Now let's look at something completely different that you can use profiles for, and let's begin by adding a folder by doing a make dir -p /home/scott/pool2, which creates a folder in my home directory called pool2. And then I'm going to create an Incus storage pool called pool2 by doing an Incus storage create pool2, and it's going to be of type directory, which just means that the files for the storage pool are going to be stored in the native file system at /home/scott/pool2. Now I'm going to create a new profile called pool2 profile with the command Incus profile create pool2 profile. First, I'm going to add the definition for the Ethernet device, and I'm going to say Incus profile device add pool2 profile device ETH0, which is the name of the Ethernet device inside of the container, and I'm going to say NIC name equals ETH0 and NIC type equals bridged, and the parent is bridged 0, which is from the Incus Containers step-by-step tutorial. Now I'm going to add a second set of attributes to this profile by doing an Incus profile device add pool2 profile, where the root disk device is going to be root, but it's going to use space in the pool2 storage pool. Now that my pool2 profile has been completed, I'm going to launch a new container called test2 with the command Incus launch images:/ubuntu/2404, the name of the container again, test2, And then we're using the pool2 profile, which will both affect the networking as well as the storage pool. And then I'm just doing a boot.autostart equals to true. So now if I do an Incus list, you'll notice that the test2 container is running out on the main LAN at 172.16.1.202. Not only that, but if I do an Incus storage list, you'll notice that we have the default pool, which is running a number of things, and then we have pool 2, which is of type directory, located at /home/Scott/pool2, but it's in use by 2 objects. We can see which objects are using that pool by doing an Incus storage show pool2. And in this case, we can see that the test2 container is using that pool, but also the pool2 profile is using that pool as well. Just as a reminder, again, when we did the Incus launch command and we specified the pool2 profile, we not only got the container running on an address on the main LAN due to the bridge profile, which I manually specified inside of pool2 profile, but we also had that container being created on the pool called pool2 here, as you can see. Let's create a profile called new NIC with the command Incus profile create new NIC. And now we're going to go ahead and add some attributes to the new NIC profile. And specifically what we're going to add is we're going to add device ETH1, and we're going to say that it is a NIC and the name is ETH1. The NIC type is going to be bridged and the parent is going to be bridge 0. So now let's do an Incus shell into test2, the last container that we just created, and let's do an apt install on net-tools. And it'll install net-tools, and let's do an if config. So inside this container, we have ETH0 that has the address 172.16.1.202, and we have the loopback connector. Let's go ahead and exit back outside the container, but now let's go ahead and add our new NIC profile to the test2 container with an Incus profile add test2 new NIC. And now that we've done that, let's go ahead and shell back into the container. In order to recognize the new Ethernet device, we're going to do a cd over to /etc/netplan and do an ls over here. And you can see that we have the 10.lexc.yaml file from originally creating the network when the container was created. And so I'm going to do a nano of 10-lexc.yaml, and I'm going to go in here and you can see that we have ETH0 above. I'm going to add ETH1 colon, and then I'm going to add DHCP4 colon true. And that's all I should really need. I'll go ahead and do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. And then I'm going to do a netplan apply. And now that I've done that, if I do an if config, I should have both devices ETH1 or ETH0 and ETH1. And you can see that they both have addresses. And in fact, if we exit out of the container and we do an Incus list, you'll see that test2 has an address for ETH0 and ETH1. As a reminder, the way I got that new Ethernet device in there was to add that profile where I did an Incus profile add test2 new NIC. And I could reverse that process by doing an Incus profile remove test2 new NIC. And now that it's removed, if I do an Incus list, we will see that test2 now does not have an ETH1 device. It only has an ETH0 device. And likewise, if I went ahead and did an Incus shell to test2 and did essentially the same command from inside the container by doing an if config, device ETH1 is gone. On my router, I have a VLAN 80 VLAN defined and being managed, so I'm going to do an Incus profile create VLAN 80. And the attributes that I'm going to add to it are that I'm going to add to the VLAN 80 profile device ETH0, where the NIC is ETH0 again, but the NIC type is MAC VLAN with VLAN equal to 80, and the parent again going through the software switch bridge 0. And now I'm going to add the VLAN 80 profile to the test2 container with Incus profile add test2 VLAN 80. And now if I do the Incus list command, the test2 container has an address on VLAN 80 of 192.168.80.192. And as expected, if we do an Incus shell over to test2 and then do an if config, and of course inside the container we have the address of 192.168.80.192 for ETH0, which is pointing to VLAN 80. Let's exit the test2 container and then do a Incus profile remove test2 VLAN 80, removing VLAN 80 from the test2 container. And now when we do an Incus list again, the test2 container is now back on the main LAN at 172.16.1.73 in virtue of the pool 2 profile that you'll remember had incorporated into it the option to bridge to the main LAN through the bridge 0 device. So realize that everything in this video described so far are commands that we're putting into a profile and then applying a profile to containers. But you can also execute these commands directly. But since this is a video about profiles, we're going to continue on and discuss things to do with profiles. So with that in mind, here's something completely different. We could do an Incus profile create snap-hourly. And that creates a profile called snap hourly. And then we can set a snapshot schedule for that particular profile. And I do an Incus profile set snap-hourly, where snapshots.schedule is set to @hourly, which means that this profile will perform snapshots on an hourly basis if applied to any particular container. Next, we can assign a snapshot pattern or how to name the names of our snapshots. And we're going to do an Incus profile set snap-hourly snapshots.pattern hourly dash, and then it's going to find the creation date, and it's going to pipe it over to this template pattern, which will be basically month, day, year, and then underscore the time in the 24-hour format. And then finally, the next thing we're going to do is we're going to establish a snapshot expiration time period, and we're going to do that with an Incus profile set snap-hourly snapshots.expiry is 4 hours. And what that will do is when we apply this profile to any container, it'll create hourly snapshots, but it will start deleting the oldest snapshot and only keep the last 4. So the power in profiles is very obvious because I probably can't remember to issue all 3 of these commands and their formats independently every time I want to apply this to a container. So now all I can do is say Incus profile add test2 the profile snap-hourly, and it will perform snapshots according to these rules that we established in this profile. And now here we are 5 hours later, and if we do an Incus snapshot list test2, it will list the snapshots on container test2. And it's actually deleted the oldest snapshot, so our snapshot expiry of 4 hours has taken place, and we only have the last recent most 4 hours of snapshots. So in summary, Incus profiles are very powerful and useful in creating and also modifying containers. And Incus profiles can present containers on different VLANs and different storage pools. And Incus profiles can make custom settings on containers without remembering all of the command switches. Incus profiles can be edited with the Incus profile edit command. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.